Uh, it's been 30 years now. I'm associated with PB industry, and 25th year in India. So since I started working with Kirby here, associated with them, to now, if I look back, there are a lot of changes that has happened in the industry. So industry overview has already been discussed in the morning, pricing and other things. There are other things which are left behind, was basically about the quality. And we have been working on designs and detailing, but one area that has been left out is the fabrication and the quality of the fabrication. And we also discussed about skilling people. Skilling people is one when they intend to work. So now I see that as we progress as a nation, now getting manpower at the shop floor is going to be a challenge. It's already been a challenge, and it is going to be more and more challenging in the days to come. Now, how do we get prepared for this? So we just are going to look at some of the innovations that are happening in the fabrication, which the technology is already there, but normally the technology comes to the manufacturing or shop floor little late, even for the manufacturing. We always adopt little later after people have used and tested it, and we see that okay, it's good to use now. So there are some innovative technologies that are available now, which I think is going to change the way the fabrication that is going to happen in the days to come. Now, you are all aware of BIM, Building Information Modeling. Now, it's been used, but not, it is not connected with the shop floor yet. We use BIM as mostly detailing software, or sometimes connecting MEPs and other processing utilities with the building model. That's all we have been using it. Now it can be used further in the shop floor. To give an example, if you have Tecla model, from there whatever drawings that comes, we have limited use of that in the shop floor now. We can use that extensively. We are only using it for CNC cutting, maybe drilling, and some such uses actually. But actually you can use it much more than that, provided you have got tools to get associated in the shop floor. So what is the advantage of this in fabrication? One is you can connect the BIM model with the fabrication, okay, seamlessly. Then you are using it for identifying potential problems, in the erection stage. Whereas you can also look at what are the problems that may come in fabrication and then address it before the drawing hits the shop floor. It is also now facilitating between the engineers, architects and the fabricator, so that you can talk in terms of the drawings, in terms of the digital information, and then see if there are any problems. Now, how do we use this BIM as we go forward? Now, one of the technology that has come is 3D laser scanning. Okay, 3D laser scanning has been used elsewhere in the world, mostly in the construction segment, where they want to scan the entire building or a portion of the building and then connect that with the other processing facilities and then see there is any problem associating with them. Now, how can we use this as a tool in fabrication? I'm happy to share that, as Cherish Building Systems, we have been in the forefront of automation. My partner and the promoter, Mr. Charan, sitting here, we have been working on this for the last 2 years and see that how are we going to bring the automation. And of course, we failed for a year, and then eventually, then we found out the solutions available in the world elsewhere. And this is going to be a game changer. This can be used for the fabrication, this can be used for quality control. There are many uses of this here. What it does is a member which is already fitment is done, with the end plates and stiffness. It scans and then compares that with the BIM drawing, tech law drawing, and then tell us potentially if there is any problem in terms of the matching with the drawing. Now, what it does is it helps us in the quality of the members which are going to be erected at the site. It potentially all the problems can be reduced here. So, it's typically scans the beams, and you can see here, as you can see here, the scanner is somewhere here, okay. So, it scans the entire member and then prepares its own drawing. This can be used also if there are members which are already fabricated or it is in place. We can scan it and make a drawing out of it whenever it is required. Now, along with this, when the 3D scanning is there, along with that, we can add the robotics. We have already installed these in our factory, and probably we are the first one to do so in PB industry in India. Maybe worldwide also, Asia and Middle East. So there are 1 or 2 players who are also doing it along with us, but we are the first one to do it. Basically, our stress is on quality and how do we bring these new technology into our industry. I'm sure people will follow this. There are issues with respect to economy of this, and somewhere we have to make a beginning. We have made a beginning, and what it does is, you can see it is used for full welding of the end plates and stiffeners automatically. Now, you will upload the Tecla drawing onto the system, and then this robot scans with the help of scanner the entire member and then gives the information back to the system and then compares that with the drawing that has already been uploaded. And once you confirm there are no issues, it does the entire welding automatically. Because we know getting welders and fitters are going to be a problem. As it is, it's a problem, and in the time to come, it's going to be more problem. Plus, whoever we are getting now, the kind of quality that comes out of it is questionable. Then there is efficiency factor. So, this will do precise work and it's completely automated, okay, and it increases the quality as well as the productivity. Now, similarly, this is something which is expensive now, and I'm sure as the day progresses, this also will be available for that. This is the same robot with the same 3D scanner. We can even make the fitment. End plates and stiffeners is automatically fitted by the robot. Because this is the area where we are struggling, fitters and welders, everybody is talking about they are not available, and I'm sure as we start progressing more and more, we will not get them. Let's take it, straight. And we don't like to have that kind of jobs. People have to progress, they have to move up the ladder, so naturally there will be availability issue. Although we are 140 crores, so it's something of a contradiction there, but we have to be ready for the future. So it does the similar thing like welding. It does all the fitment. You can see the robot picks up from the scanner, puts the end plate here, and then tack weld it. And then you send it to the full welding robot. And so this, I think, in near future we will also have this, but right now it is available only in some countries and it's quite expensive. Now, this is something which is going to be exciting. We are using 2D drawings to make members at the factory and at the shop floor. Now, you always look at the 2D drawing and then make sense out of it. The fabricator has to put a plate there. Sometimes it's looking at in a 3D is going to be a challenge, okay? And there are mistakes. So there are issues which comes up at the site. Now, with the augmented reality is nothing great. It's a reality on which you put a digital data. In a simple way, for example, you have a house, and in your living room, you want to see that how the couch is going to look. So you can superimpose the couch on the empty reality, real space. I'm not talking about the drawing. You can go to the real space, put the impose this on that, and then make whether it looks good. It's similarly here in the shop floor, the drawing can be fed onto the equipment that is used, and then the drawing, through the drawing, superimposing on the real, let's say it's an eye section. So on the eye section, you can superimpose the digital information, and it tells you where the stiffeners or end plates or any other plate, in which direction it has to be there. So based on that 3D visualization, you can do the fitment. I think this will come pretty quickly because it's not only for this, it can be used for many more construction related activities. So this is already, I think, post COVID, people have experimented a lot on this, and then we are going to get this in near future. And I think, I hope, Charan, we will be the first one to get that also. So, these are some of the innovative techniques that have the equipments that are available now, and it is going to change the way the shop floor looks in the near future. Okay. We from Cherish, we have made a very modest beginning in this direction by automating some of the activities, and hopefully we'll have many more of these things coming up, and it increases the quality and efficiency of our shop floor. That's the idea. So what it does, these automated fabrication, it's very well known. It's I've just listed few. It increases the efficiency, improves the precision, lower labor cost. There is a question mark here, how we are going to look at it. This is mostly a Westerner take on this. So as Indians, we have to see how this is going to be. Safety, yes, there is an increased safety in what we do, improved quality, and we'll have a greater flexibility. There is an end-to-end connection from what we are doing right now in terms of the BIM to the shop floor, which is not there now. If we can connect many of the activities what we already do, so there is a check. Today there is a manual intervention at many places where the errors can happen, especially with respect to the 2D drawings. Okay, and just to give some introduction about Cherish Building System, we started this journey 2+ years back, around 2.5 years back, and we have put up our factory a year back, completed that, and we are operational since last December. We are putting baby steps, but surely in the right direction. Our intentions are good. It's about quality of the product, and we are doing whatever that it takes to achieve that. So we are moving in that direction. Our mission, our vision, mission. So we just want to become a trustworthy company in the industry. I know there are a lot of companies now. There is huge competition. So we want to stand out in a good way.
Mr. Chandra Shekar, you'll need to speed up.
Yeah,
I forgot. It was so interesting. I can give you that.
Yeah. So this is the details about our factory. It's about 2 lakh square feet of covered area. These are our fabrication facility. I'm sure this is going to get increased in near future. So you can see this, this robotic. And we have also introduced box fitment, which is a requirement now in the industry. So it's an automated fitment of box Then we have double-head beam lines. It's like, one side welded, turn it around, and the second side. So two-side welding has become very common now, although I don't agree with that as a designer. But anyway, it's been accepted now by people. So CNC punching, drilling, shear machines. These are the fabrication areas, shot blasting machine, sheeting, and so whatever that takes to make a good PV is all present. Some of the projects which are ongoing now, we are doing at JSW Bellary. This is something which we just completed. This is a multi-story building, which is now completed, I think 9 stories. This is our own project, and this is an experience center that we have completed. I think I tried to give what is going to come up in the near future in the fabrication part, and many of these innovations can be used in the construction industry in other areas as well. But I just wanted to show that it can be effectively used in the fabrication of the steel structures. Thank you.